If the sun were to suddenly disappear, the consequences for Earth and the entire solar system would be catastrophic. The sun is not only the central source of light and heat for our planet, but also the gravitational anchor holding the solar system together. Its absence would trigger a chain reaction of events affecting life, physics, and cosmic stability. The most immediate effect would be gravitational. The sun's gravitational pull keeps Earth and all other planets in their orbits. If the sun vanished, this gravitational force would instantly cease to exist. However, due to the finite speed of gravity, which propagates at the speed of light according to Einstein's theory of general relativity, it would take approximately 8 minutes and 20 seconds, the time light takes to travel from the sun to Earth, for us to feel the effects. Once this time passed, Earth would no longer follow its stable orbit around the sun. Instead, it would continue moving in a straight line at the velocity it was traveling in its orbit, drifting into the cold and dark expanse of space. Simultaneously, the absence of sunlight would plunge the Earth into darkness. Like gravity, light from the sun takes 8 minutes and 20 seconds to reach us, so for a brief period after the sun's disappearance, there would be no indication of the impending doom. After this delay, the sky would go completely black, as the sun's illumination of the atmosphere would cease. The moon, which shines by reflecting sunlight, would also go dark, leaving Earth without its familiar nighttime companion. The temperature on Earth would begin to drop rapidly without the sun's heat. Initially, the atmosphere would retain some warmth, but as heat radiated away into space, the surface temperature would plummet. Within a week, the average global temperature would fall below freezing. After a year, it would reach approximately 100 or 148 degrees, making the surface uninhabitable for most forms of life. Oceans would start to freeze over, beginning at the surface. However, the ice layer could act as an insulator, allowing liquid water to persist for some time in the deeper layers, potentially sustaining life around geothermal vents at the ocean floor. Photosynthesis, the process by which plants produce energy using sunlight, would halt immediately. This would disrupt the entire food chain, as plants are the primary producers that sustain herbivores, which in turn sustain carnivores. While some larger animals might survive for a short period by consuming stored food, the collapse of ecosystems would be inevitable. Certain microorganisms, particularly those relying on chemical energy sources instead of sunlight, might survive in extreme environments, such as deep-sea hydrothermal vents or underground. Human survival would depend on artificial energy sources and ingenuity. In the short term, people could rely on stored food and energy reserves, using electricity from power plants to maintain warmth and light. However, without solar energy to power most renewable sources, like solar panels, and indirectly drive wind patterns, humans would need to shift entirely to other energy sources, such as geothermal or nuclear power. Even then, maintaining life support systems for billions of people in a sunless, frozen world would be an extraordinary challenge, and long-term survival for the majority of humanity would be unlikely. Beyond Earth, the disappearance of the sun would wreak havoc on the rest of the solar system. Planets, moons, asteroids, and comets, no longer bound by the sun's gravity, would drift off in straight trajectories through interstellar space. The solar system as we know it would cease to exist. For objects dependent on the sun's energy, such as the icy worlds in the Kuiper Belt or the atmospheres of gas giants, significant changes would occur as they adjusted to a new cosmic environment. The long-term fate of Earth and the other planets would depend on their trajectories and encounters with other celestial objects in the galaxy. Earth, for instance, could wander through space for billions of years, potentially encountering other stars. In the unlikely event that Earth passed close enough to another star, it might capture heat and light again, creating conditions for life to re-emerge. However, such events are highly improbable. The sun's disappearance would also have profound implications for the universe itself, illustrating the intricate balance required for life and stability in a cosmic sense. It would serve as a stark reminder of our reliance on celestial bodies and the fragile conditions that allow Earth to thrive. While the sun's actual disappearance is physically impossible under current understanding, it would take billions of years for the sun to exhaust its nuclear fuel and expand into a red giant. The thought experiment underscores the critical role our star plays in every aspect of life on Earth and the solar system. Thank you for watching. We have some amazing videos coming up, so stay tuned and make sure to hit the subscribe button.